now we can. Hi, Councilor McMorrin.
Hello. How's everyone doing?
All right. The first order of business is approval of the minutes of April 4th, 2024. And I would like to ask for one minor correction. On line 35, that retention ponds are not maintained by the city, not by the property owner. So we have two nots. So I'd like to revise it to say, she mentioned they are not maintained by the city, but by the property owner.
Change for retention to detention. Also.
I'm sorry, my mistake.
I mean, while we're making changes, we might as well, right?
Over there.
Okay, are there any other comments or corrections to the minutes? Okay,
I moved that we accept the minutes as amended.
I'll second that. All in favor, please raise your hand and say aye.
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 Motion carries unanimously.
Motion that.
Second. All right, our next item of business is membrane filter purchasing discussion. So, go for it.
I'll kick it off for myself. Hello, everyone. My name is Pete Blumenthal. I'm with West Tech Engineering from Salem, and most of you already know that West Tech is the city engineer for Philomath. So we're currently designing the new water treatment plant for you, and I'm here today to discuss one of the important equipment procurement stages for that project. Today's presentation will be about the process that this committee will utilize to select the membrane filter equipment for the new plant. In 2018, West Tech updated the master plan for the city, the water master plan, and one of the recommendations of that plan was that when the new plant was constructed, that it would utilize membrane filtration equipment, which is a switch away from the media filters that you currently use. We'll talk more about that later. The design of the plant's well underway, and we're at a point now where the city needs to select some specific equipment. So what's driving this conversation and the selection process? Why are we talking about this? For two reasons. First, there's a need to select equipment so that we can complete the design of the water treatment plant. And to illustrate that, I'm going to show a picture here of a stereotypical membrane filtration unit. Filtration equipment like this makes up the central part of any water treatment plant, and it's a fairly intricate piece of equipment. There's a number of connection points that you can see on the front end of this. To the right of your screen, mechanical connections. There's some electrical connections, certainly for the control cabinet that's on the skid, and there's instruments mounted all over this, turbidity, temperature, pressure sensors that all need to be captured in a data stream. Most industrial process equipment in this era is all digital, so this is kind of like a miniature computer module. So there's a lot of connectivity to a piece of equipment like this, and we can bring our design in so far, but at some point we need to know where's the pipe, where's the valve, what are the data streams that we need to capture from it. So to allow our design to move forward, we're kind of jumping ahead and we're saying, let's pick a filter manufacturer, a filter style. It has several purposes. One, it can allow them to start manufacturing because this is a long lead item. Plus then I can finish my design by saying, right, we know it looks like this or looks like that. And then things progress smoothly once we get into construction down the line. So the second reason we're having this discussion is that obviously, large capital purchases made by municipalities are required to comply with Oregon procurement. rules. So there's a process for that. You guys are well familiar with this. Just outline it briefly. It begins with the preparation of a request for proposals, an RFP. Then it progresses to issuing that RFP to the general public. In this case, we've advertised it in the DJC. So vendors and manufacturers are aware of, there's an opportunity to provide equipment.
DJC stands for?
Daily Journal of Commerce. Thanks, Chris. And then after it's been out on the street and suppliers have had a chance to work on the RFP, prepare one of their own and submit it, then we receive those RFPs, the proposals. And then it comes back to this committee again for an evaluation of those proposals. And then it bounces to City Council. You'll forward your recommendation to them. Council reviews that recommendation, and ultimately it kind of concludes with an award, formal award to an equipment vendor for said equipment. So, as I mentioned, we've prepared the RFP. We've issued the public notice for that RFP. It's been out on the street, as they say, for about 3 weeks or so people have had a good chance to look at it. One thing I want to say is that we're evaluating this equipment package under the framework of ORS 279B. That's a procurement process that differs slightly from traditional hard bid projects because it allows you to evaluate the suitability of equipment on a variety of metrics. Certainly price, but it's not the only metric that you're allowed to consider. And usually with complicated pieces of equipment like this, in some cases professional services, you want to know more than just price. It's a deeper decision than just single metric. So kind of in this presentation, I'm going to jump around a little bit. I'm hopefully going to be able to give you enough background information about filtration, some about membrane filters, how they work, kind of seed your mind with what to be looking for when we receive proposals. And proposals are going to be opened tomorrow at the West Tech office as a formal opening. I'll be there, and then I'm going to get that information brought down to Kevin tomorrow and get that into the council packets for you guys for the next meeting coming up. Committee packets.
Question?
Yes.
May I ask, how many firms out there manufacture this type of equipment? And when you say a long lead time, how long is a long lead?
Yes. So I'll talk about how many as part of my presentation, if I could defer that question. Sure. And we're going to also talk about lead time, but in general terms, some of the equipment for this treatment plant, let's say a generator, as a case in point, can take, oddly enough, upwards of a year to procure.
I'm familiar with generators.
Yeah. Unfortunately, I'm sorry, because,
I agree with you.
I'll talk about all of those ahead, so.
Okay.
Save your thought and I'll get there. Matt?
This seems like something that should be part of like a statewide purchasing agreement or something like that, is that?
It can be. That's a great question, because certainly like a generator is something that is more of a commodity.
Right.
That would be more likely to be under that umbrella.
That is.
It is then, perfect.
So we bought the other one.
Correct. So yes and no, right? It depends on what you're buying. I think it's like a paradigm on the other end of the spectrum would be like if you were procuring professional services for something, there probably wouldn't be a conventional like bidders list for that. And maybe there is, maybe not, but anyway. So this procurement method we're using, ORS 279B, allows you guys to weigh in personally and say, here's our needs as a community. This is the priorities that we assign to these different metrics. And this is the equipment that we think best suits our needs. So before we get too far into this, I just want to outline an idea that you guys can keep in mind throughout this evaluation process. I want to talk quickly about single variable systems and then multiple variable systems. So in a single variable system, decisions are generally pretty simple. Something either is or it isn't. Decisions can be made really quickly in that structure. The outcome is pretty simple, it's readily measured. Not a lot of complexity. This is kind of your stereotypical black and white scenario. And you compare and contrast that to a multiple variable system, things get a little tricky. The decisions are more complicated. The right solution needs to fit a larger set of needs. Sometimes those needs are opposed to each other and they require trade-offs. For example, if you're getting a truck with a heavy towing package, because you need that, you're going to have to give up a little on fuel economy. You can't have all of it, as they say. So we're going to step through some of these variables in this membrane equipment package to give you a better context for how this is very much a multiple variable system and not a single variable system. So not to belabor the point, I just want to give a quick example of a single variable decision. Gum. All right, you want some gum, you pick out some gum, you either like it, you don't. It's a frictionless transaction, there's one variable. Did you like it or not? If you didn't like it, you just go down a simple single variable track of buying gum, and in the end, you're done. A lot of times, these single variable decisions are also highly subjective. Like this, for example. The universe at large isn't going to come and tell you that you made the wrong decision on your pack of gum. So it's simple, it's subjective. By comparison, multiple variable decisions are harder and they're complex. So the example in this case is knee surgery. So now, this is your knee, now it's personal. And when you go into something like knee surgery, you're evaluating a complex set of factors, and all that feeds into your final decision. It influences it. You're going to be looking at the timing of that surgery. It's like, can you get a few more miles out of the knee that you have before you need to go in for reconstruction? You'll be evaluating, for example, the qualifications of your doctor, according to them. You'll be looking at the track record of your doctor, according to others. You maybe have an evaluation of the risk categories for that particular type of surgery. Are you going to go for something cutting edge? Stick with something more conventional? What about your age? Old knees heal slower than young knees. You're going to be evaluating your level of insurance coverage. The facility that you get the surgery in, some hospitals have these weird metrics on secondary infections. So again, this is a multivariable decision. It's complicated. There's trade-offs, and you have to look at it from a variety of perspectives. Similarly then, using that same multivariable system, you're looking at a membrane equipment package. Again, it's a complex set of factors. You're looking at quals for the equipment manufacturer, according to them, track record, according to others, an evaluation of the risk categories. Do they have a well-defined scope that's going to keep you on track? Do they have a installed user base of equipment that you can use as examples? Or is it a one-off? You're certainly going to look at cost, but then you talk about cost, and now is cost a front-end capital cost, or are we talking life cycle cost? Because again, if you try and push this back into a single variable, you start to get into a little bit of trouble. You're going to be looking at warranty. You're going to be looking at service and support. I mean, for any of you that have been operators, service and support can sometimes be a lifesaver. Okay, so that's kind of outlining this single variable, multivariable framework that I'd like you to just keep in mind. Back out just a little bit now and talk about water source. Oh, so what we're talking about here is not a single variable system, it's a multivariable system. I want to back out just a little bit now and talk quickly about water filtration to give you a bit of context for filtration for the equipment that you're buying. So if you look at water sources in Oregon and you talk about freshwater extraction as a resource, so this bar represents total freshwater extraction in Oregon for human needs. 70% of that comes from surface water, 30% comes from groundwater. Surface water, no surprise, is harder to treat. If there was enough groundwater to go around, we wouldn't be dealing with surface water. And it shouldn't be a real surprise to anyone either to hear that surface water is changing. Average water temperatures are rising, and that shift in temperature alone is changing the quality of the water from a biological and from a water chemistry standpoint. Well, it's 2018 that Salem had the rise in cyanotoxins. Is largely a temperature-driven variable, and their treatment plant and slow sand filters really struggled with it. Another metric you look at is forest fires. They certainly create severe changes in some watersheds. With the wildfire, you lose the loss of canopy vegetation. You get changes to the soil structure and mineralogy due to the intense heat. And that can lead to some real challenges for surface water treatment systems. So these environmental changes, combined with the increasing regulatory requirements that the Oregon Health Authority puts on you, kind of starts to put a lot of pressure on these water filtration systems. Let's zoom in real quick as we'll talk about filtration now, this 70% portion that's surface water. Surface water requires filtration to remove the pathogens and particulate matter in order to condition that water for human consumption. And when you survey all the public water systems in Oregon that use filtration for surface water plants, you find out you kind of got four major categories of filtration. First category, the bulk of it, 53%, is media filtration. This is very similar to what you guys have in your existing plant. Media filters typically have a granular material bed made of sand or anthracite or garnet, and they're designed to filter out particulate matter using a combination of two things: physical straining, but then also there's a very important chemistry process. And the chemistry process is a coagulation process, and it comes down to the fact that the pore size of a media filter is around 75 microns. You look at the diameter of the waterborne pathogens that you're trying to eliminate: Giardia, Cryptosporidium. Giardia cysts are 10 to 20 microns. Cryptosporidiums are like 4 to 6 microns. They're very small. So to give you a graphic on this, let's just assume these little black lines that I threw up there, you're looking at a cross-section of your filter media. Those white spaces in there is the pore sizes, median pore size of your filter. And as a cross-section, your water flow now is moving down through that filter bed. So on the same scale of those pores, you've got Cryptosporidium, or you've got Giardia on the left and Cryptosporidium on the right. So you can see readily that these pathogens pass right through those pores. And that's where the chemistry of coagulation comes in, because you're destabilizing that matrix of particulates and pathogens. You're allowing them to clump together to form a flock. Large particles then are retained on the filter, and so this isn't a threat. So just as a kind of a compare and contrast, membrane filters use a much smaller pore size, down to 0.1 or 0.2 microns, which is 20 times smaller than the little red Cryptosporidium dots that you see there. So it's a different separation process. It relies less on this chemistry magic, because seasonally, with a winter storm event or whatnot, your water chemistry is changing and your operators are always chasing that to get this optimal coagulation to be sure that you don't have breakthrough on your filters. So I'm jumping a little bit ahead to membrane filtration, giving you a peek, but it's a much more robust method of securing you against these pathogenic organisms. There's a small wedge, 2%, that's made up of some pretty exotic filters, riverbank filtration, diatomaceous earth. We're not going to really talk about those. 25% are cartridge filters. All of you have probably seen that. These are used typically in smaller systems. They can be a spun cartridge out of synthetic yarn or fabric, and they're basically a mesh that's designed to trap crypto and giardia. That technology is really not appropriate for the scale of a municipal plant. You see them a lot in smaller systems. But then we move on to this last category. 20% of the surface water filtration plants in Oregon are membrane filters. And Ruth, this is kind of a question to in terms of like manufacturing diversity, the sum total, all these plants in Oregon, let's give it a number, 50. 50 membrane plants in Oregon as of about this year. It's a pretty narrow field. There's about 5 vendors that make this specialty equipment. And to give this like a maturity metric, like the first membrane plant in Oregon was installed in 2004. And fast forward today we've got 50 plants, so 50 plants in 20 years. It's not a new technology. It's been gaining traction for a lot of good reasons. But this isn't like a street or water line project where you're going to get 6 bidders. I mean, the market just doesn't work that way. I mean, I don't know how many bidders you get if you went for knee surgery. I mean, kind of as a comparison, you've got a very specialized set of players. So to put some more perspective on these 50 membrane plants in Oregon, I've got a chart, and I'm hoping you can see some of this. This is ranked from the biggest plant on the left-hand column, number 1, all the way down to the smallest plant, number 50 at the bottom. And then along the x-axis, you have population size that's served. So the interesting thing is that this first plant way up at the top, that's the North Clackamas Water Commission plant. And oddly enough, that was the seminal plant in Oregon, built in 2004. Number 2 on this list of membranes is the city of Bend. They just put in a new plant not too long ago. And I think the next one down is the Albany Millersburg plant, and then Grants Pass. So you kind of start working your way down this list. All the way down to the bottom, you've got membrane plants that are serving 30 people, and Oregon Parks and Rec uses a lot of these smaller membrane plants for their state parks. You see them on smaller communities because they're kind of a set it and forget it system. There's not a lot of attendance necessarily. So if you break this chart down a little bit into thirds, let's just say the plant in terms of the population that you guys are serving comes in, if you see that red line there, kind of in the lower part of the top third. So, you're certainly in good company. And if you were to compare, let's say another kind of local reference, let's say the community size that Corvallis serves. Now they're not a membrane plant, but by comparison their population size is this orange line. So they kind of fall in there on this breakdown of membrane plants. Now,
Question?
yes.
So if you don't use membrane and you don't use media, what do you do?
That's pretty much it. You could use a cartridge depending on the cartridge filter if you're a smaller community. Most of the treatment plants filtration, I should qualify this. Media filtration is broken down into lots of different categories. There's probably 5 flavors of media.
Okay.
Right, so like Salem's plant is a slow sand filter. It's still considered media. On a slow sand plant, you're using some chemistry, but you're also using a biological growth layer on top that's kind of a gelatinous mat that traps the cryptosporidium and whatnot. So it's a nature's chemistry rather than so really, if you look at it kind of in the broad picture, for big plants, for big municipalities of your size, you really are looking at filtration, media filtration of some kind, or membrane filtration. Yeah.
And it appears as though this is a growing trend, that this is
Correct. That is the case. Yes. Yeah, both in terms of the number and the size of them. I mean, Ben's plant was maybe 4 years ago, and that's a 15 MGD, give or take, plant. So, you know, the bigger plants, there's so many nuances to this. The bigger plants use a slightly different blend of membrane technology because all of this has economies of scale. Like if you were a small park and recs firm, you'd want a totally integrated platform that's a small skid that you can just push into a shed. When you're a big municipality like Bend or Albany, Millersburg, you've got crew, you've got layers of staff that can attend to it, so you're allowed to make a different decision to fit you. And that kind of goes back to this multiple variable decision-making process. What fits the city of Philomath's needs? So while we're on this chart, I just want to talk briefly about the importance of an installed user base in terms of water delivery. Because in the last 50 years or so, there's really kind of been a big shift in how water is delivered to users. You rewind the clock 50 years or so, you really had all these municipalities were operating as one-off units, just on their own, independently serving water to their constituents. But as water resources have become more scarce, you begin to see this increased need and desire to coordinate and collaborate between utilities. This is no surprise. I mean, you look at southwest states of the US, I mean, the Colorado River is disappearing, and suddenly you have to play nice with others because you just can't make the whole system work unless you're doing trade-offs. I mean, even in Oregon, you've got the Yamhill water basin that's struggling pretty severely. And here in town, you guys are seeing collaboration with your intertie with Corvallis. So we're moving toward this kind of this deepening sense of collaboration and coordination. And that same paradigm really fits, in a sense, with the equipment that you guys are looking at providing. It's nice to have a community. For anyone that's been an operator, it's nice to have colleagues that have a similar plant up the road a piece, where you're like, man, I'm baffled by this. Can we problem solve this? And they're like, oh, we've done this, we've done that. And by the way, you haven't told me this yet, but stay away from that. So there's a sense of community, I think, that really augments and amplifies the level of service that you can provide if you have that collaboration. So the installed user base is an important metric. I mean, you could imagine if you were an operator of a one-off plant, some brand X, you're stuck up in Sitka, Alaska, operating this plant, and suddenly you get a call from the vendor that says, you know, we've thought about this as a company, we're really not interested in serving Sitka anymore, we're going to move our business focus elsewhere. I mean, your plant just got pruned. And so, you know, this is one of those multiple variables that you want to consider is this sense of community. You have resiliency because of community. And so an installed user base is one of those variables you want to look at. I'll take another segue here, talk a little bit about membrane filtration, and give you some background about what it is when we talk about membrane filtration. So again, here's this picture. It's a conventional membrane rack. The blue part is kind of a metal frame. It's skid mounted. Some of it's pre-assembled. The back half of this plant that's highlighted there are the membrane modules, sometimes called the module rack. And the front part of this is the valve rack. The modules are really pretty much just individual filter chambers. They can snap in, they can snap out. And as the name module implies, it's if you need more capacity, you add more modules. And the front end of this plant is kind of the brains. You've got a lot of valves. In this big gray box, you've got the logic, the programmable logic that drives the valves, looks at pressure gauges, temperature probes, is really driving the whole system. And then you've got some, on this front end of the valve rack, you've got instruments again. Are you meeting your reduction in pathogens, etc.? So these units are typically kind of shipped to the site, semi-assembled, and then plumbed in to the mechanical piping in your plant, connected to power, connected to data links. So these are the membrane modules that you saw on the back end of that plant. They can be individually removed for maintenance or replacement. And when you look at these modules, one of the things that Oregon Health Authority, they're the regulating agency for you. So if you go to build a plant, ultimately they step in and say, we're the guys with the check. We need to make sure that these modules are approved. So OHA has a list of approved modules. Could you potentially use an unapproved module that's not on OHA's list? You could, but that puts a bit of a risk burden on you to make sure that you can get them in compliance. If you cut one of these membrane modules open, you'll see a bundle of hollow fibers that run essentially from the bottom full length of the membrane module, and that's really is the heart of the membrane filter. The membrane material has a permeable wall, as you can see in the picture here, 0.1 to 0.2 micron pore size. Again, it's smaller than the microbes, so it physically excludes them on the face of that, outer face of that lumen. Raw water flow, and we'll get to this in a second, is coming from the outside of this lumen. It's passing through the permeable wall, and it's collecting on the bore, or the central part of the lumen, and it's peeled off as treated water. Each of this bundle of lumens that you have inside these membrane modules are potted at each end in an epoxy disc, and that unit is inserted into the module. This happens to be the top end of a cutaway of the top end of the module. And in terms of the treatment mechanism, raw water, untreated water, is flowing in through the bottom of this module, through some large pores that are outside, allows the water to come around the jacket of this membrane, kind of swirl around this bundle of lumens. And then as the pressure from our pumps push the water through that, and then that filtered water comes out the top that you saw just a second ago through the bore of each of these lumen. As you can imagine, periodically these need to be cleaned. You accumulate sediment, bacteria, and whatnot. And the process for that is, there's a couple ways. You reverse the blue arrows, the flow now, you get treated water pushing down into the lumens, pushing out. It displaces and dislodges the meat, the dirt, and then you add some compressed air into there to jiggle it all around, and you can float all that particulate matter out. On a less frequent basis, you have chemical cleaning that you can use to remove kind of the scaling and some of the biofilm that can tend to accumulate on those. And that's done using citric acid, kind of an acid base, back and forth wash. So we use high strength citric acid, and then you use a caustic solution, and you try and break up some of the longer buildups that you get on the outside of these membranes.
Question,
Yeah.
under normal operating conditions, what kind of water pressure is this?
When the membranes are new, it's really pretty low. It's about a 12 psi transmembrane pressure. And as you might imagine, over the life of a membrane, slowly that transmembrane pressure increases to about 30 psi. But you've got a terrific surface area. I mean, each of these modules, as you can imagine, this is like human hair. So, and the plant, and to speak to that, you know, it used to be that old pumps and plants were just cross the line start. It was either pump was either on or it was off. But anything these days now is all controlled with variable frequency drives. And so it's like a gas pedal in your car. You can speed up a pump, you can peel it back. And so you can respond sort of in a dynamic sense to this changing pressure profile of your media rack.
And how long does one of the cartridges last?
That depends. That's one of the metrics. It depends on the vendor. Some of the vendors have a shorter duration. They say they'll warranty it for 3 years. Others warranty it for 10. You know, there's a lot of details about the membrane modules, and I'm happy to talk about this later, because this is like, how do you pot, for example, those individual lumens in that epoxy? I mean, how you make these things matters. There's tiny details that make a really large difference. If you can imagine sticking a bunch of these straws into a liquid epoxy, you're going to naturally get a wicking process, and that capillary action is going to draw this epoxy up the outside of each of these lumen. Now, if you were to take a cross section of that, what you see is the epoxy is coming up and really is forming kind of a sharp edge right where that wicking has stopped. And so now as you get compressed air in there and flow, moving the lumens around to clean them, that becomes a fracture point. And so one of the things we've stipulated in our membrane criteria is that the potting on these needs to be dynamically, or they also call it centrifugally potted. So that preserves this flat surface, and so you don't induce a stress point on the lumens. So there's a lot of specific reasons that I've included in the RFP that you guys may or may not care about, but it's a standard of care that you will care about if I didn't do it. And so at any point, you guys can, if you want the deep dive, let me know and I can get mad.
So before it goes into these chambers, it's filtered somewhere. Is that a media filter or?
So in the process from the river, let's say from the river to the reservoir, raw water comes from the river. It's pumped to a pipe directly in. Well, it goes into a strainer, a wire strainer. That knocks down sticks, leaves, anything else that's floated in from the river, big stuff. And then after that mechanical straining, it goes directly on into these membrane modules. It comes in through the bottom, and really that's where the bulk of the separation occurs on the microscopic stuff. And then, as we're saying, it's collected in the center, and we sip it off and collect it. And then we finish our treatment, right? Chlorination, some of the other steps, corrosion control. So, did I answer that, or did I?
Yeah,
ask it again?
It's less filtered before it gets to this than I would have thought.
Yes, surprisingly less. Yeah.
It seems like that'd be easy to clog up.
Correct. Okay, so we can talk about that briefly here. There's always more to the story, right? When you talk about membrane filtration, it's a class. You have, on the coarsest end, you have microfiltration. Oddly enough, that's what this is. You can go to ultrafiltration through a whole spectrum. Ultrafiltration, nanofiltration, and you get all the way up to RO, and then electrodialysis, I suppose. The question is, you need to really pick the right technology for your needs. I mean, let's use an example. Intel uses deionized water for everything, for a very specific reason. Do you, as a human, need to drink deionized water? I mean, no. It's actually harmful to your body. And so here again, it's like, skip the deionized water. Regular tap water is good. I'm a biological agent. I can handle this, that, and the other thing. Likewise with your filtration, we're not trying to demineralize the water because that's another technology that we don't need. What we are trying to do is provide a barrier to these pathogens and that form primary health risks, and also knock down a bunch of secondary stuff, things like color, some other non-pathogenic things, aesthetic values. And so that's where we're choosing, and this is like 90% of the plants in Oregon, membrane plants, are all this microfiltration, which is kind of the entry-level version of this whole spectrum. Because yeah, if you misapply the technology, I mean, this is like picking the wrong gear on your bike. You're trying to go up a hill and you just made a bad decision because you picked the high gear that you just can't pedal. So it's all about choosing it. But yeah, it's generally more directly connected to the raw water than you would imagine. Membrane data sheet, this is in the selection packets. It kind of covers some of the parameters that we've selected that would be a good product for you. I'm not going to get into this. We'll talk about that when we get into the evaluation stage a little more. All right, there's another dimension of all this that I want to talk about, and that is really scope delineation. When you go to buy a membrane package or an equipment set of anything, it's really important to understand the scope. So the equipment package, and probably the best way to do that actually is to show you a schematic, kind of a concept of a treatment plant. You've got the main filter equipment provided by the membrane system supplier. That kind of falls here in that green square. But it's really a subset of the total equipment installed in the plant. Other things that are inside the scope of that vendor, the equipment, the membrane equipment, are things like these chemical cleaning tanks. Those are located at different parts of the plant oftentimes. You've got, compressed air receivers. You've got piping that is probably outside of their scope. But really the complicating part of this a lot of times is just the plethora of instruments, pressure gauges, flow meters, temperature gauges, whatnot, splattered all over this plant. And so there's lots of connecting pieces that need to be clearly defined, because if you're going to hand this off to a contractor to do the non-equipment components, we need to know, that's mine, I get it, or that wasn't mine, no, I don't plan on this. It just leads to a lot of ambiguity if you don't have a tight scope. So when you document all this kind of thing into a technical document, you get something like this, and I don't know if we can see that very well, but this is a piping and instrumentation diagram, and this is the guts of what you see in the plant. And this is a very technical, detailed plan. It shows, pumps, it shows pressure switches, it shows level switches, temperature gauges, strainers. All of this stuff is defined on this PNID. And what this allows you to do is to draw a very tight scope of equipment around what you're asking for a price on. This is in, this is out, this is in, this is out, and that gives you a lot of control over the process moving ahead. Yes, Ruth?
If you choose one manufacturer for your membrane filtration, does that lock you into other manufacturers for other parts? Or
Yes and no. I mean, there's a lot of things in life that are sort of canalizing decisions. Like if you buy a Dodge, you're probably not going to be able to use your backlog of Ford parts to service the Dodge. So there's some gateways where you do kind of commit to a particular vendor, and that's why it's important. Now, interchangeability. 20 years ago, when the first membrane plant was installed in Oregon, there was really not a lot of interoperability. Like these membrane modules, for example, were all unique. Every manufacturer had their own. You couldn't fit them cross-platform. Nowadays, like you've got the standard, USB port. Everybody kind of is starting to conform to a standard. While that does allow you to interchange modules, you still have another issue and another problem behind that, is because while the modules may physically fit, now the question is, are you buying a knockoff module that has a different pressure rating or that has a different QA/QC rating for the lumen material, the membrane material? So you can do cross-platform, and things are starting to head more that way. But the system that we're providing, or we're describing in this RFP, really is kind of a specific to one vendor.
Right. And I wasn't thinking so much about the modules themselves as being.
Right. So a lot of times these membrane manufacturers, like you can see in the scoping document here, they need ASME pressure vessel. They'll buy that from a welding shop, right? That's kind of a standard unit. They're assembling their scope of work from off-the-shelf parts. And so they'll buy the same flow meters that the city uses for parts of their plant. And so those parts are interchangeable. And so there's some kind of compatibility. And one of the things I've asked in this part of this framework for this RFP is like, tell me, what are you using? What are your flow meters? What are your gauges? What are your valves? So that can we service those? Can we have interchangeability with some of the other systems the city's using? So some of this gets really kind of annoyingly complicated quickly, but this is an important thing. And this is why you guys have retained somebody like Westech to sort of sort through all this and give you kind of a roadmap of don't step in the cow pies here, there, and everywhere. So this is one of the things you'll be looking at when we get to these evaluations. I've asked for a P&ID. Did you get a P&ID in your proposal? And does it kind of meet the standard of care? All right, so this is kind of a hardware discussion, and now we get into this software piece. Everything these days is digital. So our basic problem, we start at the Marys River, we need to get the NEBEC, point A to point B. So we just talked about these filters. They come in as a hardware piece. You've got some off-skid stuff, some tanks, some pumps, and you've got some instruments that are thrown in there. So now this whole equipment package is really driven and controlled by a programmable logic controller. And this is just a cabinet with an instruction set that directs traffic director for all the pieces on that. Open this valve, start that pump, speed that pump up, slow that pump down, etc. That programmable logic controller looks like a refrigerator. You can't really look in it, and so what you need is a user interface, and that is a computer that sits on the desktop. It's connected to the PLC, and the users will look at that. They'll have a graphical interface that they can manually click and select things. Now, the important part of this, that whole thing is an integrated package. That's what we're asking for, because this instruction set in the PLC is very specific to the manufacturers. And really what we want is an integrated system. Like when you order a car, a pickup truck, I mean, if you were a gearhead, you would say, send me all the parts. I'm just going to assemble it because I want that level of control. But for the average person, this is what you want. You want an integrated package. Why do you want an integrated package? Well, it really irritates the gearhead, but for the average guy, this saves you a lot of risk. It reduces a lot of risk. It puts a single source of responsibility on a vendor, and you can go to them and you say, this little box, your equipment isn't talking to each other, it's not running. Now that goes into your warranty, it goes into your service. This is specialized stuff. They are the most capable of sorting out their issues with their gear. So the idea here is that when we say membrane equipment package, it's hardware, it's software, and it's a little bit of services as well. And like we also said, you've got stuff outside of this scope. You've got front-end hardware, you've got back-end hardware, and those pieces that are not in the equipment supply scope also no surprise, have a programmable logic controller of their own and a user interface. And that is cross-linked then back to this discrete set provided by the vendor. So we're going to talk in just a little bit more about this controls and instrumentation piece, because Ruth, like you're mentioning, there's some long lead items in this equipment box, if you want to call it that. And we'll talk about how we're going to tackle that. It may be another procurement project similar to this membrane equipment, but we'll get to that. All right. This is one of my last points. So
You're doing great.
okay. So, and one of the final points I want to talk about is durability and reliability. I mean, this is something when we jump in our car to drive across the country, that's probably the first thing you start thinking about is, am I going to get from point A to point B? So what we're showing here is to illustrate this, is a chart of your annual water production. Every day of the year, starting on the left with January 1, going to the right, December 31st. And your daily demand, water demand, across the year looks something like this. Kind of a no-brainer to say that all of the water consumed in town is pushed through the membrane plant, through the treatment plant. Now, the higher demand in the summer, granted, that's buffered in part by storage. The plant isn't a one-for-one replacement, but I will say that even with the storage most municipalities have in the summer, your storage margins are thin. How fast you need to put water into the bucket depends on how fast it's coming out of the bucket. And, if you're on the shoulders of this curve, on the left and right in the wintertime, early spring and the winter, your demand is low, your reserves and your margins in your stored water system are fatter, are more generous. So if you had an outage, let's say, in the winter, that might not be such a big problem. Because in the winter in Oregon, everyone's pretty much flush with water. If you did have an outage, you could rely on your intertie with Corvallis. They've got water, your demands are low. It's a low ask, small ask. Now, compare that with an outage at the peak. It's just a different story. And if you compare like demand, this green line that I just drew on there, that's like your median winter time demand. So if you're driving, let's say you're driving 65 miles an hour at that level, this is a 3.5 times peaking factor. So you go from 65 miles an hour to 195 miles an hour. Now, I don't want to be alarmist, okay? Because my job in this is to make a plant that can operate at that high speed. But what I'm trying to say here is that this is an undeniable trend, and it's a consumption pattern that influences risk across the year. And so I guess I'm just going to say this, leave you with this kind of point. So this, this technical advisory group, the group of us, and city council, is directly responsible for the delivery of water into town. And we all know that water can be kind of a hot button issue. It's a critical resource. So here's the scenario. It's the 4th of July, maybe it's frolic and rodeo. It's July. Water demand is peaking. People are using water for everything. You combine this with the fact that it's dry out, fire hazards are elevated, people are shooting flames into the air because it's 4th of July. So you may have some fire fluids added into this mix. So I think the question for me as I look at this is, what is the value of a gallon of water on that day? It's just a metric. It's one of the many metrics to look at when you're trying to decide about reliability and durability. And not just reliability in the short term, but over the life of the plant. All right, we're getting to the end. Getting real close. Okay, so where are we at in this overall procurement process? We've talked about this a little bit already. We've issued the RFP, given public notice. Tomorrow, we'll be receiving proposals at the West Tech office. We're going to prepare the packets, really get that material beat up for you guys to start looking at. And then there's a group of 3 things that we're going to be doing at the next meeting. We're going to evaluate the proposals, score the proposals, and make a recommendation to council. Now, those 3 kind of steps are done by this group. And then, like we said before, that recommendation gets passed to council. Council makes the award. What I'd suggest, perhaps, as part of our next meeting, when we do this 3 items in this red box, is, at your option, maybe we have a small roundtable discussion. There might be some time for Q&A. People can contact me in the interim as well with any kind of questions. And then we'd move on to scoring the proposals. And you'll each have a score sheet with some metrics that, you can the score sheets will be part of the packet that I give you from the vendors, so you can kind of look at this and say, are these things lining up? Do they look, good or whatnot? All right. I only have my concluding comments, but I need to make a sidebar just right here. This project as a whole, because of long lead items that we've been talking about, ever since I think COVID hit in 2019, we basically saw some serious disruptions to supply chains. And so what we're trying to take on with this project is a phased procurement approach. And like this membrane package, we're trying to get some of these long items evaluated in a competitive environment, because we're required to do that. But start the contracts rolling, start purchasing this, having the vendors be able to start manufacturing some of this stuff, so that when we do come to bid the project to a general contractor, we're not sitting there waiting for a year. I mean, you guys know well that contractors, they want to glue the parts together and get out of there. And it really puts a lot of pressure on their contracts when you ask them to stop, basically, and absorb a year of lead time. It's just not a good mix. And so to the extent that we can have this problem solved for them, or I should say teed up, they can do what they're best at. They can come in and start integrating these things that we've already made some purchases on. So toward that point, the equipment package the membrane equipment package is one thing that we're doing early. I alluded briefly earlier that there's some electrical equipment that probably needs to be looked at as a separate procurement package. And the trick with electrical equipment, it's long lead, and you get into some programming issues that you don't want to hand programming as a skill set off to a general contractor. It's just not their skill set. You guys have a system integrator that you work with for your existing water treatment plant. And so what I would suggest, and we'll talk about this more later, is as this specialized electrical equipment comes in, to the degree that it can be programmed and integrated as this gray box so that the contractor can take it and plug the Ethernet cable in and it runs, that really simplifies things for you. It gives you a better quality project because you've picked a qualified integrator to stitch it all together. I mean, you get into all kinds of crazy stuff like UL listings. If you need to modify an electrical cabinet, you just can't do that because you're going to avoid your UL listing. So you need a UL listed shop. And it's a specialty. I mean, it's like these things these days. I mean, this document here was the entire specification set for your existing water treatment plant. This is 1985. I mean, this document, today's world, is 2 volumes. I mean, I don't have an answer for why we're doing this, but it's complicated. And so to the degree that we have these elements that we can say, this is a specialty piece of work, takes a long time to get it, let's get it started. Generator is a similar sort of category. Matt, like you said, that's a little simpler because it's a box, it's a commodity unit, but it takes a long time to get here. So let's start that process rolling. So that was my sidebar. So now, the last thing, okay.
That raises a question for me. So are these types of systems manufactured in the United States?
Yes and no. So systems like the electrical control gear or the membrane?
Or but either?
Both, okay. Let's talk about membranes quickly. If you want to talk about the global supply chain, this is the thing these days. I mean, we're about to go to war, or who knows?
Who knows, right?
Who knows?
Yeah.
Who's making the PVDF membrane lumen inside your module? Is that a company that I won't, or a country that I won't name? In this case, you can get this lumen from a friendlier company, Japan. You know, Asahi is a huge company. They're highly specialized. They make a lot of these PVDF membranes. So do you pick a vendor that has a friendly supply chain, friendlier, or do you pick somebody that's got a supply or a device in their system that can't be provided outside of maybe a country that is suddenly non-friendly? Now, you talk about electrical switchgear. I mean, a lot of this stuff, it's like this. It's designed in the U.S. It's manufactured partly in Mexico. Some of the parts come from Sweden. It's all integrated in Mexico, shipped across the border. I mean, and this is complicated because, again, I don't know why we do this, but there's been economic pressures that have created it. So there's a need for some of these little boxes, like how do we safeguard your long-term investment? And, you know, one of the things I would be looking at, you know, if I'm in on the mix on this, is that, you know, do our membrane modules come from somebody like Japan that we have more ready access to? The U.S. does not currently make a lot of this membrane based product. Somewhere I read that when I think COVID hit, or it was Hurricane Katrina or something, like Port of New Orleans was just all jacked up and closed down. And the odd analogy was chicken parts were causing a real problem because a chicken is subdivided into lots of parts. The white meat stays here in the US because there's a huge market for that. The feet and the heads get shipped off to Asia. The dark meat goes to Eastern Europe. And all these ships were just scrambled up trying to get these chicken parts. I mean, this is the world we live in. It's like a diverse and intricate, complicated place.
I sell high precision GPS equipment and total stations and things, so I'm intimately familiar with what you're talking about.
And this gets back to the multivariable. There's not always a magic. I mean, we're trying to do some of this with chip manufacturing. We're trying to bring some of that to the U.S., but those things take a long time to develop. So you make this decision with some trade-offs and some, you know, known risks, and you make the most balanced decision you can. Like I said, this is my closing statement. Multiple factors, we've talked about these. Qualifications, track records, an evaluation of your risk categories. Can you do the well-defined scope of work? Because that affects risk. Do you have enough installed users? What about cost? Warranty, service and support. All these metrics, you know, become part of your grading platform for our next meeting. And so, really, remember, that's not the solution.
One more follow-up question then. So, like specifically about the membrane modules, do those have a shelf life, or could you stockpile, say, 5 years
That's a good question. I
Materials.
believe I think they may be shipped with it's like a lot of elastomers. You know, it's
They'll deteriorate over time regardless of whether.
I don't know the direct answer to that. I mean, I think when they're shipped, they have probably a saline solution to keep them hydrated. You know, but it's a thing, something that we could explore. But this gets back to the user base, right? Because if you're in what's the wildebeest in Africa, if you just stay in the middle of the crowd, you know, it's like there's lots of people around you that are operating similar systems. You've got an industry that says, hey, or a manufacturer that says, hey, we've got 10 plants in Oregon. That's a legitimate part of our core business. We need to solve that, right?
That was my follow-on question then, was like, are there value-added resellers or whatever in this supply chain that, so like if we don't want to stockpile the stuff, could we rely on someone else to do that?
Yes, I think I would have to check. That answer is going to depend on the size of the company and the particular vendor. Some of these people that supply, companies that supply this are bigger, deeper resources. So that would be a depends answer. Depends on who the company submits.
And it, is it the soda ash here last year or so that there was a big
Right.
shortage of, and what we
Right.
saw was a lot of the bigger plants that had bigger stockpiles were able to sell it or, do it to some of the smaller plants or more necessity of it and stuff. So there definitely is something to not being the lone wolf, right? Or picking the one plant that nobody else has ever used before. Definitely, I think we'd want to shy away from that and try to get a plant that somebody or somebody's around us are familiar with utilizing, ordering similar equipment, all that kind of stuff. I mean, I think that's going to play a big part in the decision.
Which is also, I think, what we do now is talk to some of the other cities nearby when we purchase alum and something else and share a load with them.
Sure.
Instead of saying we need it and we're paying a lot more by it
For a bulk
with
delivery.
everybody
Right.
and take the delivery and just makes it cheaper. So
I mean, this is kind of why all of us have a job, is because we have to sort through this network of headaches. That's why I buy aspirin.
In bulk with your neighbors?
What's that?
In bulk with the rest of the
Both
office?
with the neighbors. My little community of engineers, we're all headaches. So, just my last point here, I don't want to beat this, it's not a single variable system. This is a multiple variable system. It's complex, it involves trade-offs, it's got a long-term impact. Now, if you try to reduce a multiple variable system to a single variable system, you're gonna get into problems. It's a little bit like looking only one direction when you cross the street. Your mom told you to look both ways for a pretty good reason. So, this is your town, it's your community. Make a smart decision.
No pressure.
No pressure. Isn't that the real world, though?
Yeah.
I mean, who's off the hook? Unless you're buying gum, like my earlier analogy. And the next time you go buy gum, you're going to be like, this is a relief. It's like,
Thank God I only have to choose from 20 kinds of gum.
yeah, if you don't like it, it's not like your knee surgery where it's like, yeah, you should not have picked that doc. Yes.
Do you know how many proposals you're getting in?
I'm hoping for 3. I have one on my desk right now. That's not necessarily a bad thing. I mean, here's the thing. Again, this is specialized equipment. So let's look at this from the perspective of the one that I have. They don't know. They've prepared their bid, assuming that this was advertised, that there's a field of players. So quite honestly, it might be that is the low bid. If I had 20 of them, that might be it. I don't know. And the only way I would know is if I had a deep field. So just because you have a narrow field doesn't mean that it's, a misallocation or some kind of a, travesty. If that's the system, that's reliable, meets your metrics, and that's, you know, at a price point. And next time we're here, Jeff Buskirk, who's the city of Jefferson's Public Works Director, I mean, he can weigh in on some of this and say, like, what his experience was as a Public Works Director. So, you know, we would like to have a deep field, but in some ways, I mean, even like with your sewer project that I think you guys just put out the bid, I mean, you're gonna call up some contractors and you're gonna say, hey, we got this awesome project, and they're like, no, we're not even gonna bid it. We're just too busy. We're too busy.
That was gonna be a question I had, is this, you showed us about Oregon, but I'm assuming it's similar across the whole US.
Yeah, I mean, I could have like a favorite vendor that just tells me, I'm sorry, they're booked. Now that, again, that sounds like kind of maybe a problem, but now you have to look closer at it. What's the nuances of that? I mean, maybe they weren't the low bidder, you know?
And what kind of a cost range are we talking about?
I would say this is probably in the $2 to $2.5 million range. Part of what we're doing is we're buying like you saw earlier, a membrane rack that's expandable. That's my goal, so that when you go to expand your plant, you can buy more modules rather than wholesale tear out and retrofit. It's going to depend a little bit on what the proposers, you know, I've asked them in the RFP, you know, for example, I've said, you know, here's the plant size that makes best use of the small area that we have right next to the plant. It's outside of the floodplain. You know, show me how you're going to fit your equipment in there. What reserves do I have for future expansion? So this kind of all becomes like part of how do we do this? Are the tanks too tall? Do I need to make the building a little bit bigger? Am I adequately covered for that? So unfortunately, lots of details.
Do municipalities use untreated water for fire flows?
Around here that I know of.
Yeah, I can speak to that. I know California is starting to use recycled water for outside use. It gets a real problem because the problem is we've got one set of pipes. I mean, all of
You know our fire department can draft out of the river.
can draft. Yes.
They don't do that on a typical basis.
Okay.
They went down and practiced on the marriage a couple times.
We do have some like industrial users that have a fire system that's totally separate from potable.
They usually have a pond of their own.
They have their own water source and pond that they use, and then that energizes. I mean, because you have two different systems here. Honestly, it's like you've got, you know, mom and pa that are filling their kettle with drinking water, small demand. Now you've got a tank or a fire hydrant that's pulling up that's all kinds of water. Like, for years, we've just had one set of pipes in this country. You've got to be able to hit the peaks and the lows.
I lived in Utah, several communities there have dual, you know, they use it for irrigation
Yep.
and fire flow.
Yep.
So you can irrigate at a much lower rate than
Yep.
what your treated water would be.
Like all the bibs in those paradigms, all the bibs on the outside of your house for washing cars, watering lawns,
Marked.
are all marked.
Yeah.
And then you always hear getting this mind shift to like, oh, there's a cross connection. They hooked up their water line or kitchen sink to the.
You can also just tell your kids to go drink out of the hose, right?
Yeah, families from moved to Utah.
That's why these books are getting thicker, because the world is getting more complicated. Now it's like, maybe there'll be a day when you have to look 3 ways before you cross the street. Drones.
Yes. Well, I think this is fascinating. I'm going to invite you to a cocktail party so you can just
Right.
talk for hours.
Well, I'm happy to. I'm happy to. This is a small time that we have here, and it feels, part of my brain feels grossly under optimized because it's like, oh, don't you want to know about this? And don't you want to know about this? I think hopefully we've presented enough that gives you a working knowledge. So, and I'm available to stick around, so, the formal part is done, and now it's back to your.
Okay, I have some here. Are there any more questions for Pete?
I think if we can, I didn't think this through real good on the order, but hitting the next week's meeting while Steve's here.
Oh, okay.
Or in case they wanted to leave.
Good thought, thank you.
And what we were looking at was opening bids tomorrow morning and getting it's from the vendors out Friday to give you the weekend at least to look them over. Is that, I don't know how thick these are. In time and is a little less than a week enough.
None of you guys are gonna be experts on membrane filtration plant. But again, the question really is, do you have enough of a working knowledge to look at a proposal, to look at the score sheet, like the metrics we talked about, you know, what's their installed base, what's their price? And then ask some questions of me if it's technical stuff, like, are we making a mistake here? So I think it's doable, and again, I'm offering my time if people have questions ahead of that meeting. Mr. Me.
And we'll be discussing some of each criteria
We certainly
next week,
can.
right?
We can discuss it.
Or debate it or.
Yeah, because if you've got questions before we score these things, I mean, it's reasonable to get smart.
Sorry if I missed something. Did we have a meeting scheduled?
Tentatively, I had it penciled in for August 1st, next Thursday.
Okay. Make sure.
That was just the question was, does the committee feel that getting packets Friday, hopefully Friday if all goes well, and meeting next Thursday gives them enough time to review everything?
Sure.
You may not know, right? I mean, if you
Yeah,
feel
I know.
overwhelmed, then we got a plan B.
How thick is that? How many pages is the proposal you have? You know?
It'll be thicker than you want.
Then one on your desk. We'd be sending that out, right?
But most of it, you know, I can prune it down and tell you, like, I mean, a lot of the metrics that they're submitting is stuff that I care about. I mean, it's a framework that I've already set up that this is like minimum qualifications. So I can go through that and kind of pare it down. And so maybe what I'll provide in the packets is the Cliff Notes version, you know. But if you want the full packet, I can just give you that. So
I probably would like to see it, so I don't have to go back to you.
Sure. Absolutely. Why don't I do this? I'll depending on what we're looking at, how many vendors I get, and how much paper I have. I mean, I'll try and kind of categorize it a little bit.
Okay.
But you'll have the full packet, and I'll give everybody the full packet, honestly, just so that you have.
Ruth's setting herself up to be our backup operator.
Yeah, exactly.
Color in a pinch.
I think if you turn to page 227, you'll see.
Do you want me to point out the typos and grammatical errors?
Yeah, but then Gary, you'll be like, was it Foghorn Leghorn? Now, son. I wouldn't do it. And then you're just like, calculations.
So August 1st, are we doing 3 o'clock again?
You think that's enough time to evaluate, or?
I know it's enough
Go
time for
to-
me. I mean,
To go with 3 for a couple hours?
3 to 5?
yeah, I'm good with
Work
that.
for you, Steve? Okay.
And well, I'll raise a red flag if it's too much. And Christopher, that works for you?
I think it should, yeah.
Thank you. I think that concludes this portion of the meeting, and the only, other named agenda item is the Main Street medians discussion, which I know nothing about.
Sure, I'm trying to remember what we talked about.
I think just discussing
Like time frame more.
budgeting,
Yeah.
or seeing about how everybody feels about budgeting money into landscape medians.
Yeah, so quick history, the landscaping that was placed in the medians when the highway first got redone lasted 8 years, 10 years, and then started to fail. The plant material itself was too tall, the roses were too tall, the trees weren't getting, it was too hot, they were getting root bound, they were starting to split and everything else. So we, based on several varieties, that landscaping material was pulled out. And because it wasn't a budget item at the time, we were looking for something cheap. We went with the river rock to get installed back in there, because we could afford it and the maintenance was going to be easy. And so we kind of just punted. The intent has never been to just leave the river rock in there forever as it is. And so we're at a point now, as much as some in the room may want to just concrete over the entire thing and not have meetings.
Make it look like grass.
Well, that,
Concrete and paint it green.
that was the big thing is it's all, 24 inches of rock below.
Then you got asphalt.
And then there's the old asphalt road, so drainage, getting anything to grow is difficult, so they mounded the dirt up to give it a little bit more dirt. And then on some of the side streets pulling out, you couldn't see because of the mound, because of the roses, because of everything else. So we were always combating that. And we went out and weeded it, I think 3 times a year, which would last about a week. And that was $2,500 a time to set up traffic control and put somebody out there and everything. So that was a big leading cause of going to the river rock that was low maintenance.
Who takes care of the island where there are roses?
The Lions Club.
That looks
And
beautiful.
Public Works.
I'm gonna say in conjunction, Public Works.
Yeah. The Lion Club
It was-
volunteers get out there,
It
but
was stunning this year. The roses are just beautiful.
Well, that was
Last
Public
year we
Works.
trimmed them back because they'd gotten so overgrown. So
Oh,
I sent my guys out there. They were doing we took our hedge trimmer, put them down. They need to be done on a regular basis.
Yeah.
yeah, I'm sure they do.
They're not designed to
Anyway,
be this tall all the time.
And the original plan was to have more volunteer groups throughout the community adopt these medians and take care of them. And what we've seen is only one group has held through and done that, right? And the rest of them, it's all fallen to Public Works to take care of. So it's become an expense.
And to some of their defense, the safety issue was,
Yeah. Yeah, we don't want our
Yeah.
volunteers out there in the median, middle of the day, cars whizzing by without everything. So all that said, we still get complaints about just the river rock alone in there. And so we've started discussions, we've been in discussions about what to do in there. I don't think the river rock goes away, but we've looked at some aspen or some other low growing plants that could grow in there to add a little bit of greenery, a little bit of landscaping in there that would be pretty drought tolerant. It's still gonna be a burden and maybe even a greater burden on Public Works to go in there and maintain that than what it is today. But even today, we have to go in there and we have to weed, we have to spray, we still do some litter cleanup and stuff, so. We don't have a budget for it this year, so we wanted to at least bring that topic to this committee to see what your appetite was for on doing some type of improvements to the medians throughout town. I'm not recommending that we go back to finding trees that we can put in there and a guaranteed low grow rose bush, because I don't think those exist, right? Everything gets big and tall, so. But I would like to do something personally, because I do get complaints from it, but,
Hens and chicks.
what's that?
Hens and chicks.
Hens and chicks?
With succulents.
Super low growth.
No.
they looked at other stuff like art, putting
Go up tall and they don't.
pieces, some of the bigger decorative rock, and that ODOT has their regulations for vehicle vehicle safety stuff, so we couldn't do a lot of that.
Okay. Well, I would like to see something more attractive. Not at the cost of human life. Okay.
I can stand for you if you'd like.
Okay.
It's a pretty low bar. Short of the cost of human life, though, we're willing to discuss it.
It really boiled down to being a frustration for us with the cost, and
They're not irrigated either, right?
yeah, it's no irrigation. To get to a water line is down a long ways. It's well over 10 feet deep through there. But the guys would go out, spend a day out there weeding and everything, and then within a week or so, you'd start seeing it grow back up, and
It's
Yeah.
like my yard.
So
The rock will help with that, but, usually, and you look as you drive around, everybody's driven around and seen, I mean, I won't call out names, but there's cities you go through and their meetings look worse than ours, right? Far worse than ours. I think for the most part, ours, we do spray the weeds, for a few weeks there, you got dead weeds standing, and eventually they fall over and they blow away. And, for the most part, I don't think ours look horrible. I think that they look like they're just simple, right? It's river rock, nothing fancy. But there are communities where they look really, really nice, and you can tell that they've put some money and effort, and they put an annual budget number towards maintaining those medians and keeping them up and spending the money to do that. So that's the question, is where do we fall in this? We got all this money that's went to the streetscapes, to taking care of everything from 14th South, or 14th West. From 14th East, we've got the medians that are full of this river rock. As a side, or as an added note, I would say that we've kind of set a precedence with that now. When Benton County did the improvements on Chapel Drive, what did they put in their median? River rock. Why river rock? Well, that's what the city's got out on the rest of it. So, we're kind of going to reap what we've sown, and that this is our standard for medians is river rock. And the question is, do we want to, is it worth the money to spend to look at doing something a little bit different than that, knowing it's going to be an increase in their expense? We can maintain medians without killing anybody, right? It's just going to cost money.
So could we do like containers, and do similar to the way we do the hanging baskets, that someone volunteers can go along and water them occasionally? Obviously bigger containers than a flower basket, but not much. Just put like 8 or 10 of those around.
Christopher.
I just was very excited when I saw this on the agenda for today, because I know I've been bugging Chris about it a little bit, and I've mentioned it to Kevin and Gary, so this is very exciting. And I am totally comfortable spending some money on it. I think it's one of those things that I think for us, since we have to deal with all the other intricacies of running a city, it seems like a minor thing. But to folks who just live here and drive on that road every day, and don't have to deal with all the other stuff we know about, I think it does make a big difference in terms of just feeling like the community is nice and livable and welcoming. It is kind of the front door to Philomath, so I don't think we should spend millions and millions of dollars on it, but I think just having a nice, welcoming and sort of vibrant front door is important. And especially because I think the analogy that I feel like Chelsea has been using is that when you redo all your kitchen cabinets and you don't redo your counters, then all of a sudden your counters look really ugly. And I think we're going to run into a situation like this if like half of Main Street is new and beautiful and perfect, and then the other half is still this. I think I think you can kind of drive by without noticing it too much right now, but in a year, I think it'll be very stark, the difference. So I would love anything we can do to kind of spruce it up a little bit.
Thank you.
sounds like you'll be remodeling the kitchen
That's what I
before
heard.
long.
They're away.
Why don't we, again, not a huge time crunch on this, we just want to start the discussion. Maybe I'll throw a recommendation out there to the committee if there's, gonna do some Google searching or look at, snap some photos of other cities and stuff that you like, that seems like it's not over the top. that looks nice, maybe a little bit nicer, that would work at a median where you've got traffic both ways. Right, I mean, the islands are a little different because you get a little more space in there, but when you're talking just these medians, you really don't have a lot of room to work. Even for watering, you're talking about a truck with a light flashing, and maybe a truck behind it, directing traffic to go around. Even to go and water those, it's a task, right? Again, we're highly capable of doing it, but it's still gonna be an added venture to take care of them. But if you see photos or you want to acquire photos of stuff, why don't you just send stuff over to Kevin? He'll kind of pull it all together and bring something back, either probably not next meeting when we're talking this, but here next month, or a month, couple months out. Pull together, look at a couple different options and kind of get a direction going. I'm looking to just get enough information that when we get to next year's budget, we can say, hey, we're gonna put some additional street fund money into these medians and here's the plan. And maybe it's not all of them 1 year, maybe that's a 2-year plan or a 3-year plan or something, but then there's gonna be an ongoing maintenance dollar that needs to follow with that as well. So whether that's a specific line item in the budget that we adhere to it, or we just recognize that street fund budget's gonna need to come up some. But right now, without a plan in place, there's nothing to put money towards, so. If Kevin, if you're comfortable taking that task on, collecting the data from folks and preparing something here in a couple of months to bring back on examples of things that look nice.
Just send them to, either my email, which is gary.black@flomaoregon.gov.
2 hours.
2 hours.
2 hours.
Or the pw@flomaoregon.gov. One, that way Gary can also see them at the same time.
Don't forget the grass look with the concrete. It looks good.
AstroTurf, yeah,
AstroTurf.
there you go.
That has come a long way. I have a yard that's all AstroTurf and it's beautiful.
You got a park right down there on.
Yeah.
Yeah.
I was just checking it out last weekend. It seems like everything's going great with that.
How much do they worry about weeds coming through on that? They ever have to worry about weeds coming through on the AstroTurf stuff?
If you got concrete underneath it, just kidding.
You better not come through on that one. We'd be in trouble. There's so much rock in there that it's gonna take a long time.
You'll still get little things from just seed that
Stuff that
germinate,
flies
whatever
in.
you can, it pops right out. It's not usually too bad.
Can you lay it over top of river rock?
We'll figure a way.
Rather than pour concrete on the whole thing.
It'd be a little lumpy, but yeah.
Nobody's walking on it.
Nobody's walking on.
That control density backfill, it just levels, washes out.
Thought as a model of the rolling hills of Philomath, right? This is the scale model as you're coming into town.
And the one by the OSU would be Mary Speak.
Yeah, there you go. Perfect.
A few little figures of buildings inside of it.
All right, I think as we deteriorate, I was,
We're onto something there.
There was other business here,
yes.
and I was wondering if we were gonna circle back at any point and talk about funding street improvements, alternatives. We kind of talked about it like 9 months ago, and then we haven't really talked about it again.
Oh, like the gas tax.
Yeah, that type of stuff.
We can certainly do that. I'm not sure. I think we'd have to wait until after the proposal review. Does that make sense?
Yeah, I don't mean like next month or something like that, but it would be nice if it was somewhere on in the plan.
Are you thinking additional revenue streams, or are you just thinking of ways to fund street projects, including?
Kind of both, but it seems like we've exhausted a lot of the discussion about things that are readily apparent, and maybe different streams are the way to go about it.
Got it in my meetings to hold and plop it in when we had shorter looking meeting, but they've all been run.
Yeah, that's the part.
About as much as anybody can stomach, so I haven't included them yet.
Yeah, and I appreciate that.
Would you go so far as to consider some kind of fee or tax or?
Yeah, absolutely.
Yeah. Okay. things to look forward to. All right, then I will adjourn this meeting for today. Thank you all of you, and thank you for a great presentation.
Thanks, Steve.
Yeah, thanks, dude.
Thanks, Councilor McMorrin.
Thank you. I hope there won't be a quiz on all of that next time because I retained probably 10% of it, but I appreciate it.